Welcome to Quadratics Day 3, video number 2. In the last video, we left off with me saying that the table is not the most accurate way of finding some of these values because the table is very limited in what values it gives you. So we're going to use another feature of our calculator that's going to be more accurate and a little bit faster for us. Okay. For the most part, the table is nice to set a window and kind of look at your values and to double check your values. But for the most part, we're going to want to use this calculation menu in order to do these things from now on. Okay, so we're given the problem, what if a model rocket is being launched off the ground, which means it starts at 0 feet at 0 seconds. What would the path of the rocket look like? Here's the equation that models the path of the rocket. Okay, again, height is a function of time. So you've seen I've gone ahead and labeled my graph with time is on the x-axis, height on the y-axis, and I chose some values because I already know those values. So we want to answer the questions: what is the highest the rocket reaches? How long will it take it to hit the ground after being launched? And how long will it take the rocket to reach 100 feet high? In other words, very similar questions to what we answered in the last video, but just using a different feature of our calculator to do this. Okay, so we're going to need to pull up our calculator again, and we're going to go to the y equals menu. So back to y equals, and I'm going to put in the new equation. So I can keep the negative 16x squared. Then we have plus 150x, and then I'm going to delete the rest of it. So we have negative 16x squared plus 150x. So now I'm going to hit graph. And you notice my graph is way off. But I can see when it hits. So I can see at 0 seconds, and that looks like just under 10 seconds my rocket is going to hit the ground again. Okay, so my window, I'm going to go and change my window here. My x minimum, what does my time start at? My time starts at 0. What is the x maximum? The x maximum is, let's go a little bit more than 10. I'm going to go do 12 just so we can clearly see where that hits the x-axis. And then x scale, all this means I want to go up by ones. My y minimum, I'm going to make my y minimum, let's see here, negative 100. Now normally we'd say, well, a rocket doesn't go below 0 feet. But I'm going to tell you and show you in a little bit why I chose to go a little bit below our minimum. Now our maximum, this is one that we're going to have to play with a little bit here. So I'm going to quickly look at my table. So I'm going to go back to my table. You should know how to do that by now. And at your table, you can see that at 5 seconds, it looks like a rocket, it looks like might be its maximum at about 350. So my y needs to go up to at least 350. We're going to go a little bit more, maybe say 400, just to be safe. So I'm going to go back to my window, and I'm going to make my y max 400. Now the y scale, what do I want to go up by? Well, I don't want to see 500 tick marks between negative 100 and 400, so I'm just going to say let's go up by 25s. I think that's a good number. Okay, and then let's hit graph. Okay. And as you can see on your graph, I can see a nice shaped parabola. What I'm going to do is see why I chose to go a little bit below the x-axis, because I'm going to want to see this point, this intersection point here, because I'm going to be able to find that. So I want to see a little bit above that and a little bit below that. Okay. Now most of the features that you're going to use to find these are going to be found in your calculation menu. That calculation button is right there in blue. So to get to that, again, you're going to have to hit second trace, which is now called your calculation menu. The 0, this one, number 2, the 0 will find an x-intercept for you. Number 3 and 4 will find either a maximum or minimum point for you. Our parabola has a maximum. In other words, our rocket doesn't go higher than something. Sometimes if a parabola opens up, or not sometimes, all the times if the parabola opens up, it has a minimum. Okay, and then number 5, we've used number 5 before when we did exponential functions to find the intersection of a horizontal line and a exponential function. We're going to do the same thing for a quadratic. So we're going to use 2, 3, 4, and 5 in what we are doing. Okay, all right, so let's go back to the lesson, and it says the highest point the rocket reaches. This is our maximum. Okay, so go back to your graphing calculator, and we're going to use number 4. Now you can scroll down to number 4, or you can hit the button number 4. Now notice down here, it says left bound. What this is asking you to do is choose a point on your graph that is to the left of where you think the maximum is. This is clearly to the left of where I think the maximum is. I think the maximum is right about here. So I'm going to choose a point that is to the left of that. So I'll hit enter. Then it says right bound. Well, I want to move to the right. This point is clearly to the right of where I think my maximum is. Bounds mean these two lines that you see on my screen are kind of boundaries for where I'm looking for my maximum. Now it says guess. So I'm going to move over to where I think I'm going to guess it is, and hit enter. Okay? So left bound, right bound, and then guess. Okay? Ours looks like it's at 4.7 seconds. We're at a maximum of 351.6. Okay, so go back to our lesson. So this question number 1, our maximum is 351.6, and this happens at 4.7 seconds. So at 4.7 seconds. Okay. Next question, how long would it take to hit the ground after being launched? Well, if I think about my graph, the ground is right here. So I need to figure out what that point is. That is what we call a 0. So I'm going to go to my calculation menu. So go second calculate, second trace, which will calculate, and that is number 2. Number 2 is finding the zeros or x-intercepts. Okay. In order to that, you're asked the same question, left bound, right bound. So you're going to choose a point that is to the left of your intercept. My intercept is right here. The point to the left, where my cursor is, that is to the left. Now to the right would be below that point. And now you can see why I wanted to see a little bit more of my screen below that point. So right bound, enter, and then again, your guess. Where do you think it happens? You don't have to be right on it. In fact, here, I'll put it above it. As long as you're close, it will find it. Okay, and let me erase this so you can see it. So this happens at 9.4 seconds. Okay, so we'll go back to our lesson, and at 9.4 seconds is when that's going to happen. All right. So when does this rocket reach 100 feet? Well, before I do that, I'm going to graph some points. So I have our starting point as 0, 0. We said at 9.4 seconds it hits the ground, so just under halfway there. And then at 4.7 seconds, we're at 351.6. So 4.7 is right about here, and I'm going to go up to 350.1 something, so just about there. So here's my graph. Graph is going to look something close to that. Actually, not bad. Okay. The last question says, how long will it take to reach 100 feet high? What I'm going to do is I'm going to put a line at 100 feet. And you can see that I'm looking for this intersection point here and that intersection point there. To find those values, what you're going to do is use your calculator again. So go back to your calculation menu. Like I said, everything is pretty much in that calculation menu. And when we're looking for the intersection of two lines, we want to use number 5. So first curve, what that means is, actually, sorry, go back. You're going to have to go to y equals first. So sorry, go back to your y equals. And you're going to have to graph that second line. We need to put in the y equals 100 line and then hit graph again. Sorry. So go to your y equals, enter y equals 100, and it should look like the graph that I drew before. Now what you want to do is you want to find the intersections between the red line and the blue line that you see on my screen. So go to your calculation menu and go to number 5. First curve means, is the blue line one of them I want to find the intersection for? Yes, so hit enter. Is the second one the one I want to find the intersection for, the red one? Yes, hit enter. And your guess. I'm going to move to the right here since I'm closer to this one, and then you're just going to repeat the process for the left one. So hit enter again. So we got about 8.7 seconds, we're at about 100 feet. So 8.7 comma 100. Now you're going to have to repeat the process again to find the other one, but you've done this before. So this happens at 0.7 and 8.7 seconds. Okay, so from now on, pretty much most of what we're going to do is to use the calculation menu, but you can use the table to kind of help back up your answer, or if you have some nice values, you can use it there as well. Okay, the problem with the table is it doesn't always give you. For example, the 0.7 and the 0.87, that would not appear in our table because our table is going up by ones. Okay, all right, so that's the end of the video. Move on to answering example number 3, and then move on to your homework.